Michael Freilich from NASA is with us at the Space Symposium in New Delhi. Welcome, Michael. Please tell us what are your thoughts on the symposium here? How important a gathering like this?
It's a fantastic symposium. The number of people and the great range of international people who are here is very, very impressive. And the fact that so many heads of agencies gave such substantive and passionate talks today demonstrates, I think, the importance of the problems that the space agencies are taking on behalf of all of humanity.
Can you elaborate on the presentation that you gave here today about the Earth science missions that NASA has undertaken in the recent years?
NASA, like our sister agencies around the world, has the technology and the science to actually make, for the first time, global measurements of many different variables in the Earth system. Our objective at NASA is basically twofold: to understand the Earth as an integrated system that is not just the individual processes, but the connections between the processes so that we can predict how the Earth will evolve under changing climate conditions. And secondly, through the vantage point of space and the understanding that we get from our research, to turn that information into specific information products that can be used by users who don't necessarily have to be satellite experts in order to provide direct societal benefit. What I say about what we in the space agencies and NASA in particular does in terms of Earth science is everything that space agencies do is challenging and interesting. But what we do in the area of Earth science is also important because we can increase the quality of life for every person on Earth.
In such a scenario, how important are international collaborations?
International collaborations are absolutely essential. The problems are too large, and the necessity of having many different measurements very frequently from space simply requires that all of our species get together and that space agencies work together in coordination in order to make the measurements that are needed by the science community. But making the measurements is not enough. Once we make our measurements, we have to make them freely and openly available so that researchers can use all of the data that are required for solving their problems, not just the data from their national satellite.
Remote sensing instruments have featured quite heavily in NASA's budget requirements every year. So, what kind of advancements are you looking at?
The Earth Science Division budget, that's my division in NASA, is about 11% of the agency. And about 10 years ago, when the fraction was rather smaller, we got some reports from independent advisors who noted that the U.S. Earth observing system from space was in danger of collapse. Since then, we have been working to revitalize our Earth observation constellation of satellites while still preserving the balance with research and applications and technology development. Looking forward from now in early 2016 until about 2022 or 2023, we are looking to launch another 16 missions, including major new missions such as NISAR, the NASA ISRO synthetic aperture radar mission, which will revolutionize measurements and understanding of ice and ice flow, of vegetation around the Earth, and of solid Earth processes that could lead to earthquakes and other geohazards.
Can you tell me about the new trends in Earth observation industry when it comes to remote sensing?
Technologies are being developed all the time, and that's a specific part of our program to make new measurements of different quantities and to make better measurements of existing quantities. So on the books, we have plans and investigations to make better measurements of atmospheric carbon dioxide, greenhouse gas, potentially methane, wide swath measurements of ocean surface topography, more accurate measurements of ice and ice motions, and a whole variety of new approaches to making measurements from space that involve constellations of small CubeSat type satellites. So everything from measurements of new variables to new ways of measuring old variables are being pursued by not only NASA, but by our other sister space agencies around the world.
If we talk about imagery, do you think data is moving towards commoditization?
Imagery, basically high resolution meter scale or sub-meter scale red, green, blue visual imagery is one thing. But in fact, in NASA Earth Sciences, we concentrate on moderate resolution and multispectral data. So we actually don't get down to the 1 meter or 2 meter resolution area. We tend to be approximately 10 meter resolution for microwave measurements and 30 meter and higher resolution for other frequencies. At those levels of resolution, even though the data are extremely useful for science, there is really not an economic business model that anybody has shown to work for exchanging or selling that data. What is a promising economic area is what I call the middleware. People who take the raw measurements that the governments provide, and put them together, assemble them to make focused information products to efficiently answer questions of specific user communities. That's where I believe that money is to be made and profits are to be made in this, not in the exchange of data.
That should be all. Thank you so much for talking to JBIS.
Thanks very much.